Hello guys, welcome to a new video of solving SL ARORA electrostatics problems. So in this video I am going to solve a numerical problem, okay, for a triangle like structure where three charges are given at three different corners. We have to find at this position net force in this position. All the charges are given. First q1 equal to 1.5 millicoulomb, q2 is 0.2 millicoulomb, q3 is minus negative 0.5 millicoulomb. We know that milli value is 10 to the minus 3. Okay, you have to remember these negative power values and positive power value, that is you should decode them. Like I'm giving something example, like okay, if negative, this is deci, centi, milli, micro, nano, pico, can go like this. Deci 10 to the minus 1, centi 10 to the minus 2, milli 10 to the minus 3, micro 10 to the minus 6, nano 10 to the minus 9, pico 10 to the minus 12. You can also tell me in the comment section about the further things, that is deci, centi, milli, micro, nano, pico, femto, yepto, jepto, etc. given in the first year SL ARORA book. And in positive side it will be kilo, mega, giga, tera, peta, like this. Okay, you can say these things in the comment section. Let's see. Okay, these are also important things. Here the charges is in millicoulomb, and the distances are given. R1 is given as 1.2 meter. This is also in SI, and R2 is 0.6 meter. So all the things are in SI, so the force will be calculated in Newton. If this is in CGS, then force unit of force will be, tell me the answer in the comment section. Okay, so this is a triangle. Here the charge is given at which the net force is to be calculated. So this is a positive charge, this is a negative charge. The positive charge will exert a repulsive force on this, let it be F1, and the negative charge will exert an attractive force on this, so let it be F2. Okay, as this force is in this direction, this is in this direction, as this is a right angle triangle, the angle is 90 degrees, so this angle will also be 90 degree. When the two vectors are 90 degree in angle, so their superposition will be like this, cos 90 will be 0, so their net resultant magnitude vector will be a square plus b square root over, right? So we have here f1 is 1 by 4 epsilon q1 into q2 by r1 square, f2 is 1 by 4 by epsilon naught q2 into q3 by r2 square. Okay, so now f net f1 square plus f2 square root over. Okay, this is the theoretical part we solved, but now the main important thing is that how we solve it numerically. Okay, when I was also studying plus 2, I was also facing some problems like solving these big numerical quantities where the 4th power, where the 6th power, even the 10th power problems are given in JEE NEET problems. So we are not going to those levels, but at these levels I am giving some tricks or giving some ideas which can be very useful or somehow useful in our future problems, or we will also use them in our videos, in next video series. Okay, so what here we have to find f1 square plus f2 square root over f1. We have to find out the common things so that we can take them common, their square and a root over, they will be cancelled out, they will be go outside like neutral, power 1. Okay, so this thing and this thing is common in both 9 Newton per minus 9 q2 is given common in both, and 1 by 4 pi epsilon not common in both, so they will be can be taken common and taken outside. What remains? q1 square by r1 to the power 4 plus q3 square by r2 to the power 4. Okay, now this is numerical. If calculator is given, we can find it easily, but now see how we can find it in our manually. Okay, so 1.2 to the power 4, 1.2 can be written as 0.6 into 2. The power will be, we know that a into b to the power m is equal to a to the power m into b to the power m, right? I am using this to find this. Okay, now we can take common this now. Okay, So things become now becoming simple. So as it is to the power 4, so the square root will be to the power 2. Okay, so now becomes this, squaring this becomes this, squaring this becomes this, and squaring 2 to the power 4 is 16. Okay, now 2.25 can be written as 2 to 5 into 10 to the power minus 8. Okay, 2.25 can be written as 2 to 5 into 10 to the power minus 2, right? I am using this. Okay, so 2.2 by 10 power minus 6 will be written like this. So this becomes 10 power minus 8 comes here, and we have also solving this 10 power minus 10 power minus 4, 10 power 5, 9 into 2 by 0.6 square, that 0.36. So now here at this side 2 to 5 by 1 6 plus 2 5 into 10 power minus 8 in common, so you can take outside, that will power will become 10 power minus 4, 10 power minus 4 and 10 power minus 10 to the power plus 5, that will be 10, and this is 9 into 2 18, and this is 0.36 in the denominator, right? So 25 into 16, if we take this as on the denominator, so it will be 2 to 5 plus 400 by 16, and this becomes 0.36 can be written as 36 into 10 power minus 2. So 18 by 36 it becomes 1 by 2, and 10 to the minus 2 in the denominator becomes go to this side becomes 10 power plus 2. So 10 into 10 power plus 2, that is 10 power plus 3. Okay, and now 2 to 5 plus 400 by 16, 6 to 5, 16 root over 4, 6 to 5 root over is 25 into 10 power 3 by 8 Newton, and 25 by 8 is equal to 3.125 into 10 power 3 Newton, and this is our answer. Okay.